Hello, dear learners. Today I welcome you for lesson 4 of chapter 1. Here is the contact information. If you face any difficulty in today's lesson, you can contact me. So, the learning objectives of today's lesson are that you should be able to know about the screw gauge. You should be able to describe how to measure a variety of lengths using appropriate instrument, that is screw gauge, which we are going to discuss today. So the content which we are going to cover in today's lesson is why we need screw gauge, parts of screw gauge, how to read a screw gauge, and in the last but not least, practice questions are given to you. So what is screw gauge? Screw gauge is used to measure the diameter of objects that are too small to be measured with vernier calipers. In previous lesson, we have seen about the vernier caliper. That vernier calipers are used to measure internal and external diameter of objects. So here we are saying that screw gauge is going to be used for the measurement of diameter for small objects. For example, diameter of pencils, diameter of wires, diameter of for ball bearings, and of such small objects we have to use screw gauge. So here is the picture. You can see that screw gauge is somehow like this. Parts of screw gauge. So here we have some points which are basically pointing towards the parts of screw gauge. So here is the first point, point number 1. It is known as anvil. It is fixed. It is non-movable part. And the second is spindle face. This part is spindle, and this edge or this end of the spindle is known as spindle face. That is the second point. Here the third point is indicating that this is the spindle, and spindle is movable part. It can move to and fro here in the screw gauge. And after this we have this scale here. It is known as barrel. It can be called as main scale, and in some books it is also written as sleeve. So this scale, which is here on this side, in between this frame and this thimble, this is the main scale, or you can call it as barrel or sleeve. After this we have thimble scale, which is also known as circular scale. And the sixth point is that ratchet. Basically it is used to move this spindle. We rotate this ratchet, and in place of that movement, what happens, this spindle moves to and fro. And spindle lock is also present here. In vernier caliper we have seen that we have retainer to lock the movement of the jaws. Here we have spindle lock to fix the movement of this spindle. And this part is known as frame, and this is the thimble. And we have 10th point, that is datum line. It is known as datum line, this horizontal line. You can see here in upcoming slides you will see that how much importance of datum line is. So now we are going to see that how to read a screw gauge. So if you see step 1, turn the thimble until the anvil and the spindle gently grip the object. So you have placed the object here. Here is the anvil, and this is the spindle face, or you can say this is a spindle. You have to turn the spindle unless or until the object is properly gripped between anvil and spindle. So once the object is properly gripped, the ratchet will start clicking. So then turn the ratchet until it starts to click. So here's the ratchet. So if you see here, we are basically measuring here the cross section of area of wire, or cross section of wire. This is the object is wire. We are going to measure the diameter of wire. So if you see here, we have labeling of parts is also available here. So this horizontal line is known as datum line. Here we have thimble scale, and this part is known as main scale. We have thimble scale is marked in divisions of 0.5 millimeter in this thimble scale. So if you see, this part is magnified and the view is here. So if you see this magnified view, here you can see that we have some marks above this horizontal line, which is known as datum line, and we have some marks below this datum line. So what is the difference between these marks which are present above the datum line and which are present below the datum line? If you see this above scale, here we have increment of 1, 0, 1, 2, 3, 4, 5, and so on. And the scale which is present below the datum line, here we have increment of 0.5. If it is 0, we have here 0.5, 1, 1.5, 2, 2.5, and so on. So basically what is happening, the scale which is above this datum line is having increment of 1 mark, and the scale which is below this datum line is having 0.5 increment in the scale. So first step which we are going to perform after holding the object between anvil and spindle, we are going to read the main scale reading. So to measure the main scale reading, what we have to do, we have to read the scale before this thimble. So at the edge of the thimble, whatever the reading we are achieving here, we have to note down that value that will be main scale reading. If you see here in this example, 5 is here on main scale, then we have 5.5, 6, 6.5, 7, 7.5, 8 is here, and this line is before, or you can say at the edge of the thimble. So this is known, the value which is known here, it is 8.5 millimeter. In our case, the example which we have taken here, the reading which we have measured from main scale is 8.5 millimeter. After reading this step, or you can say after reading the main scale, we have another step which we have to perform, that is step 3. In step 3, we have to read the thimble scale, or you can say a circular scale. So in thimble scale, we have 50 divisions. If you see 0 and here is 45, so at 0 it is going to complete the 50 divisions. So each of which is 0.01 millimeter. So to take the thimble scale reading, what we have to do, take the thimble's reading opposite the datum line of the main scale. So it means here is the datum line, this is the horizontal line which is also known as datum line. Opposite to this datum line we have thimble scale. On thimble scale we have some marks. We have to note that mark which is perfectly aligned with this datum line, okay, or the scale, or the point on the scale which is perfectly matching with this datum line, perfectly aligned with this datum line. We have to note down that division. Take thimble reading opposite the datum line of the main scale. Here in our example, this 40 division or the 40 mark is opposite the datum line, and it is also perfectly aligned with this datum line. So we are going to take this or note down this reading, that is 40. So we have 0.01 millimeter, or you can say this is also known as least count. Okay, and this is the smallest reading. So we have to multiply this 40 with the least count. So we get 0.40 millimeter here from the thimble scale. So after measuring thimble scale reading and main scale reading, or you can say barrel reading, we have to add these two readings. So in step 4, you can see diameter is found by adding the main scale reading to the thimble scale reading. So if you see in main scale reading, which was step 2, here we have calculated 8.5 millimeter, and on thimble scale we have measured 0.40 millimeter after multiplying this 40 division with 0.01 millimeter. After adding these two readings, we have the value, that is 8.90 millimeter for the cross section of wire. So in this way you can measure the reading of screw gauge. So how do we avoid zero errors when using the screw gauge? Last time in last lesson we have seen that in vernier caliper we have some types of zero error. So here we also have some zero errors. Zero error, it occurs when a zero of thimble scale. This is thimble scale. If you see here this picture or this one, this is the zero of thimble scale, and zero of thimble scale does not coincide with the datum line of barrel or main scale. Okay, we have only one datum line, and which is present on barrel, or you can say main scale, and when the spindle touches the anvil, means when there is no object, at that time if this datum line is coinciding with this zero, then we have no zero error. If zero of thimble scale does not coincide, here if you see one example, that B part, it is showing that the zero of thimble scale is not coinciding with the datum line of barrel or main scale. Here it is also not coinciding with the datum line, so we have then some zero errors. So either it will be positive zero error or it will be negative zero error. When it will be positive zero error, it means the zero marking on the thimble scale is below the datum line. If you see here, the datum line is here and this zero is below that datum line. So it will be your positive zero error. If the zero of thimble scale is above the datum line, then we will be having negative zero error. So here is the procedure that how you can avoid positive zero error and negative zero error. And it is somehow similar to the one which we have seen in the vernier scale lesson. The step 1 is first join the anvil and spindle face, and if the zero on the thimble scale is below datum line, then see which division on thimble scale is coinciding with the main scale. And same is the case for here if there is negative zero error. What the difference will be that the zero on thimble scale will be above the datum line, and then we have to see which division on the main thimble scale is coinciding with the main scale, or you can say with the datum line. After that we have step 2, in which we are going to multiply the coinciding reading with the least count. The value achieved is zero error reading. In negative zero error, what we do, we subtract the coinciding division or value from the total number of divisions. As we have seen, we have 50 total number of deviants on the thimble scale. For example, 47 value on the thimble scale is coinciding with the datum line. What we will do, we will divide 40, we will subtract 47 from the total number of deviant, that is 50. 50 minus 47, we will get some value, and then the difference that we are going to achieve is going to be multiplied by the least count. The value which will be achieved is known as zero error reading. After measuring the zero error reading, we have to measure the reading of the object by using screw gauge. We have to note down the main scale reading and thimble scale reading. Same is the case for negative zero error. After measuring the main scale and thimble scale reading, we have to add those two readings. And those two readings will give us one reading that is known as incorrect reading. That is known as incorrect reading. It will be not the correct reading unless or until we will not include zero error reading in that reading. So in positive zero error, we are going to subtract the zero error reading from this incorrect reading. Then we will be able to have the correct reading. So if you see mathematically, main scale reading plus thimble scale reading minus zero error reading, then you will be having the correct reading. In negative zero error, you have to add the zero error reading in incorrect reading, which you have calculated in step 4. Mathematically, if you see here, correct reading is equal to main scale reading plus thimble scale reading plus zero error reading. Now let's see the examples here, that how we can calculate zero error if there is, for example, positive zero error, here is negative zero error. In first example here, if you see, the zero of thimble scale is aligned with the datum line, or you can say this thimble scale is matching with the datum line of main scale. So it means there is no zero error. The two zeros marks coincide. There is no zero error. So we are only supposed to here observe the reading of main scale and the thimble scale, and just add those two readings, and we will be having this one. No zero error correction is required here because there is no zero error. So if you see here in this example, 5, 6, 7, 8 and 8.5 millimeter is the reading which we have measured from the main scale, or you can say from the barrel, and 40 is the deviation which is aligned with this datum line. Multiply this 40 with 0.01 millimeter, you will be having 0.40 millimeter. Add this 0.40 millimeter in 8.5 millimeter, you will be having this reading, and this is the correct reading because here we have no zero error. There is no need to correct the zero error. So if you see here in the next example, only the difference is that we are going to change the instrument, and we are now going to measure the reading of the object with that instrument in which we can have positive zero error. So if you see, the zero is below this datum line is here and it is below this datum line. This thimble scale zero is below this datum line, which indicates that here we have a positive zero error. Zero mark on datum line to the left. Left means it is below on side from this datum line. So we have a positive zero error. So which deviation is matching with this datum line? We have to note down that reading. If you see here on thimble scale, 0 is here, next reading is 1, then we have 2, then we have 3, the third reading is matching with this datum line. We are going to multiply this third deviation with 0.01 millimeter, and we have achieved this reading, that is 0.03 millimeter, which is achieved after multiplying 3 millimeter with 0.01 millimeter. This third deviation is going to be multiplied with 0.01 millimeter. This is the positive zero error. Now, after measuring the positive zero error, we are going to measure the reading of object. So if you see here, by using main scale, the reading which we achieved, that is 8.5 millimeter from the main scale, and here from thimble scale, which deviation is aligned with this datum line? It is 41, 42, 43. So multiply 43 deviation with 0.01 millimeter, we will get 0.43 millimeter. Add that 0.43 millimeter in the reading which you have measured here on main scale, that was 8.5 millimeter. So you are achieving this reading after adding main scale reading with thimble scale reading, and the reading is 8.93 millimeter, and this is not the correct one, this is incorrect. Now we have to subtract this zero error from this incorrect reading. After subtracting, we are having this value 8.90 millimeter. So the positive zero error is subtracted from the incorrect reading. After subtracting zero error, you can see that we are having the same value when there was no zero error, because object is same, only the difference is coming because the instrument is having some error in it, and we have to remove that error. So how we have to remove? We have to first measure the zero error without placing or gripping the object. So same is the scenario for negative zero error. In negative zero error, if you see the zero is above the datum line, and here what we are going to do, we have to note down which deviation is aligned with the datum line. It is 46. 47th deviation is aligned with this datum line. Total deviations we have on thimble scale 50. So 50 minus 47 is 3. So multiply this 3 with 0.01 millimeter, you will get the negative zero error. Now, after measuring this negative zero error, move towards this next step. Here you have to measure the reading of object. Measure the main scale reading, measure the thimble scale reading, and after that add this reading in this incorrect reading. If you see here, 35, 36, 37 is the deviation on thimble scale which is aligned with this datum line. Multiply this 37 millimeter deviation, 37th deviation with 0.01 millimeter, and you will be getting 0.37 millimeter. When you add this reading of thimble scale, that is 0.37 millimeter, with the main scale reading that was 8.5, you will get 8.87 millimeter. After that, to correct this reading, you have to add the zero error here, and after adding, you are again achieving the same value which you have achieved here after correcting the zero error, and when there was no zero error. So it is 8.90 millimeter. So here are some practice questions. Question 1. State the reading of the micrometer screw gauge in the figure below. So here two figures are given to you. You have to observe here that either there is a zero error here, because this figure is indicating when the object is not in between anvil and spindle. So now you have to see that either there is any zero error or not. After that, you have to observe the reading of the object. If there is zero error, then you have to correct the reading after measuring the observed reading. So you have to drop the answers of this question in the comment section. For example, if anyone is going to drop the answer in the comment section, what you have to do, you have to first write question 1. Zero error is equal to whatever you have measured. After that, place a comma. Then observed reading is equal to whatever you have measured. Then place a comma, and corrected reading is equal to whatever you have measured. In this way, drop your answers. If you are going to drop, I will be replying either you have measured or observed the correct reading or not. And here is the question 2. It is also similar to the question 1, and same scenario. I am going to tell you that what you have to do if you are going to drop your answers in the comment section. Write question 2 first, then zero error is equal to whatever you have measured, comma, observed reading is equal to whatever you have measured, and then corrected reading is equal to which you have measured. And as you will be commenting there, I will be replying either it is correct or not. If it is correct, I will be mentioning there. If it is not calculated or measured correctly, I will be telling what is the mistake or what are the answers for these questions. So that was related to today's lesson. If you have not subscribed my channel, do subscribe it. Do not forget to hit the like button. Thank you so much.